So speaking about the base theorem, the people get a bit confused and they start questioning, okay, why do we really need to know the base theorem? What's the real use case, real application in the life? I mean, where can we really apply it? So the clinical studies, one of the contexts that the medical researcher has been using a lot base theorem, especially in the diagnosis of the diabetics, cancer, like given the test result, if positive or negative, what's the probability of someone having a cancer or not having a cancer or diabetic or any other kind of illness. And here is a specific question. We will look at one of these cases where it says that a particular study showed that 12% of men will likely develop a prostate cancer at some point in their lives. A man with prostate cancer has a 95% of chance of a positive test result from a medical screening exam. And a man without prostate cancer has a 6% chance of getting a false positive test result. So what's the probability of that a man has a cancer given that he has a positive test result? It's an interesting study, and this is the perfect use case for the base theorem. So let's recall how what's the formula of the base theorem. So base theorem we write as following. So in the context of event A and B, the probability of event A happening given the B is already happened equal to the probability of event B given event A multiplied probability of event A and divided probability of event B. So this is our let's say base theorem. And in our case, what do we know already? We know that the study shows that 12% of men will likely develop a prostate cancer. So how do we write that? So it means that the probability of having a cancer is equal to, in a decimal number, 0.12. And we also know that a man with a prostate cancer has a 95 chance of positive test result, meaning that probability of having positive test result giving someone has a cancer is equal to 0.95. Okay, this we already know. And we also know that a man without a prostate cancer has a 6% chance of getting false positive test result. And this we can write as following. The probability of having a positive test result while someone not having a cancer is equal to 0.06. So far what we have done, we just copied everything from the given problem into, we wrote it down as the probability formulas that we will apply later on. And to write down the formula, so we're gonna do the following. So we will write it as following. So what we have been asked is that what's the probability of that the man has a cancer given he has positive test result. So the probability of having a cancer giving man has a positive test result will be equal. So we're gonna apply exactly the same as to this formula. So in our case, it will be probability of having a positive test result given someone has a cancer multiplied probability of having a cancer, then divided probability of having a positive test result. So if we look carefully, we will see we already have most of the values that has been given inside our formula. For example, we have already this value, which is here. Then we have also probability of having cancer, which is here. What we are missing is actually probability of having a positive test result. So we have to find that one, and after we will just simply plug the values into the formula to get the final output. To do so, we're gonna use it's a method called a tree diagram. It's one of the easiest one to visually understand and also get the missing value. And we're gonna do that one. So this is our tree diagram. So we know that probability of having a cancer is 0.12. So we will write down it here, 0.12. So this is having someone has a cancer. Then someone which doesn't have a cancer, so we simply will do someone not having a cancer 1 minus 0.12, which will give us the value of 0.88, someone not having a cancer. Okay. Then we also know that while someone has a cancer, given the test result is a positive, as we have seen earlier, is this one 0.95. So it means cancer and having a positive test result, it's going to be 0.95. So Likewise, we know that when someone not having a cancer but having a positive test result is equal to the, as we have seen here, is a 0.06. So we're gonna, it means that someone having a probability of having a positive test result while someone doesn't have a cancer, so is equal to the 0.06. So this is our positive. And in the same condition, if we follow it, someone having a cancer but with a negative test result, then 1 minus 0.95 will give us 0.05 with a negative test result. And the same which we apply here, someone having a not having a cancer with a negative test result, 1 minus 0.06 will give us 0.94 with a negative test result. In order to find the missing the value, which is probability of having having a positive test result, what we need to do, we need to calculate the probability of having a cancer with a positive test result, this one, and the same way we need to get these values, having a probability of having probability of someone having not having a cancer with a positive test result. So meaning that we need to have probability of someone having a cancer and the positive test result, plus we need to add probability of someone not having a cancer and having a positive test result. In order to find that, we are going simply for the first one to find the probability of someone having a cancer and a positive test result. We just need to simply multiply two product of 0.12 is gonna multiply with 0.95, and we will add 0.88 multiplied with 0.06. So if you calculate these ones, so 0.12 multiplied with 0.95 will get a 0.114 plus, and this one will give us 0.0528, and this we will get a 0.1668. This is the probability having a positive test result. So if we plug these values into our formula, which is earlier we wrote it as following. So let me just copy it. Okay, so this is our formula. So I will simply add the values here. So we know, so the probability of having positive test result with a cancer is a 0.95, gonna be multiplied with the probability of having a cancer 0.12, divided, the result we obtained was 0.1668. And this will give us, after calculation, we see the 0.683 or 68.3%. So what does this? There is a chance of having there is a 68.3% of chance of having a cancer given the test result is positive. But what about calculating actually the probability of having not having a cancer with a positive test result? So it means we will do 1 minus 0.683, which gives us something like 0.317, which is equal to the 31.7%. So there is a 31.7 chance of someone not having a cancer with a positive test result. So this is very interesting result that reveals interesting information. So we should be always careful with the test result. Even so, we have a positive test result, but there is still 31.7 chance of someone not really having a cancer. So I hope that you learned something about the Bayes theorem and how you can easily apply it within a specific problem. So see you in the next videos.